Hey guys, Mr. Corbin here and Miss Powell, and we are your eighth grade teachers for this year. And we're going to start off with a couple of help lessons. Going to try to get these on so you can access them whenever you want to be able to use them. And sometimes you'll see these show up on Google Classroom in my classroom or Miss Powell's classroom. So we're going to start off with some power rules. Power rules deal with how you multiply bases that have exponents to them. Okay, and so Miss Powell's got a board pulled up on the document camera. Miss Powell, what are we looking at?
Okay, the big number is going to be what's called your base.
Okay.
So I always think big base. That way I put the two B's together.
Okay.
The little bitty number, you make it like a smaller and up above. This is the one type of function in math they don't have to have another symbol. They just make the number a little bit smaller. And that 4 tells you how many times that 3 is to be repeatedly multiplied. So basically, what do you think the exponent is telling you?
Well, a lot of times students think that it's going to be 4 times 3. And so we're not multiplying the base number times the exponent. What the exponent is telling you is how many times to multiply the base number times itself. Isn't that what you're saying?
Yes. So sometimes when I first start doing these to keep myself from getting messed up, sometimes I put 4 blank spaces.
I think that's smart.
And then I go back and think I've got 4 blank spaces, exponents, repeated multiplication. So I go back and put my multiplication dots, and then I put that base in each one of those 4 slots.
Right.
So 3 to the 4th basically means 3 times 3 times 3 times 3.
Right. And so obviously 3 times 4 is 12. So we know that that number is going to be a lot bigger than 12. So it's never multiplying the exponent times the base. The exponent tells you to multiply the base that many times itself.
So you can put this in the calculator, and 3 times 3 would give you 9. 9 times 3 is 27. 27 times 3 is 81. So sometimes they will actually ask you to evaluate it. Now, if they ask you to evaluate it, it'd be 81. Sometimes they'll just give you the problem 3 times 3 times 3 times 3 and ask you to simplify it, and you can turn it into that condensed problem 3 to the 4th.
Yeah, and that's 2 really good vocabulary words right there. When you see the term evaluate, that means go ahead and reduce it down as far as it can go. Simplify a lot of times just means to go ahead and you can leave it in exponential form.
So 3 to the 3rd. Now, they both match, but the big number, remember, is the base. The little number is how many spaces I need. So I need 3 spaces for my repeated multiplication. I'm repeatedly multiplying the base of 3. So 3 times 3 times 3 is what that is worked out to longhand. Now, if it asks me to evaluate, I go ahead and find the answer to that, which is 27. So what do you think 3 squared, Mr. Corbin, would be?
I don't know. Is that going to be 6, Miss Powell?
No, because you're not multiplying the base of the exponent.
Oh, that's right. So again, and I'm just saying that so you guys, because a lot of times if you look at it just real quick, you're going to think, oh, well, 3 squared, that's got to be 6, right? Well, no, it's 3 times 3. So the exponent tells you to multiply the base that many times itself.
Now, this is kind of seeing a pattern here. I had 3 to the 4th, so I wrote down 3 4 times. 3 to the 3rd, so I wrote down 3 3 times. 3 squared, I write down 3 twice. So now I get to 3 to the 1 power. So how many times would I basically have to write down a 3?
Well, it's going to be 1 time.
Yes. Now, do you see how I just wrote down A3, which is equivalent to 3 to the 1? So if I have just a standard number that I wrote down, if it doesn't have an exponent there, you can put a 1 there and it means the same thing, which we hardly do that. We just put the number 3.
Right. So what you're saying to me is that if I have a number or even a variable that we're going to see later on, and there's not an exponent, there really is an exponent there. It's a 1, right?
Right.
That's important to remember.
Now, let's go back and we're going to look at the values of these. So get rid of all that stuff so it won't be confusing to you. Okay, there's a pattern here. I had 3 multiplied by itself 4 times. That gives me 81. 3 multiplied by itself 3 times is 27. 3 multiplied by itself twice is 9. And just 1 3 is 3. Now, looking at those values, how can I continue this pattern going all the way down? How do I take an 81 and turn it to a 27, a 27 and turn it into a 9, a 9 and turn it into a 3? What's the pattern there? Sometimes in math, you look and see, what are they doing?
Yeah, I think the pattern's pretty easy if you know your multiplication tables. There's, I think, some division going on here, isn't there, Miss Powell?
Yes.
Aren't they dividing by the base number every time?
Yeah, how come? Why going down are we dividing by a 3? What did we lose each time? Every time we lost an exponent, we're losing a what? A base. Because we had a 3 to the 4th, now we got a 3 to the 3rd. So instead of having 4 3s up there, I only have 3 3s. So it's like I'm dividing one out each time. So to get from 27 to 9, divide by 3. To get from 9 to 3, I divide by 3.
Right.
Now, if I'm here, what would I have to divide 3 by?
Well, again, if you divide it by 3.
So when I divide it by 3, this is one of those weird rules that you've got to know. What is 3 divided by 3?
Well, it's 1. Any number divided by itself is 1.
So in this case, I've got 3 to the 0 equals 1. Now, let's look at another base number. Let's go base 5. So starting with the same process we did before, what, Mr. Corbin, would 5 to the 3 be written out longhand?
Well, again, I know it's not 15 because I never multiply my bases times my exponents, so I'm going to do 5 3 times.
So 5 times 5 times 5. What about 5 squared?
Well, obviously 5 times 5, 5 2 times.
Okay, what about 5 to the 1st?
5 1 time.
Okay, now if you see, I'm running out of 5s here, right? So let's go and evaluate these. 5 times 5 times 5 would evaluate to be 125. 5 times 5 evaluates to be 25. 5 just evaluates back to be 5. What are we dividing out and losing each one of these steps?
Yeah, dividing by 5 every time.
So if I continue that pattern, what would be 5 divided by 5?
Well, it's going to be 1.
It's going to be 1. Now, the problem we did a minute ago with 3 to the 0, it came out to be 1. I just did another problem with a totally different base with an exponent of 0, and it came out to be 1. So what pattern do you think we might be finding?
Well, what this is showing us is that any number to the 0 power is going to equal 1 when you simplify it.
Okay, now some of these numbers get bigger, so we're going to work it out again as far as writing it out using multiplication. So 8 to the 4th is written as how?
8 times 8 times 8 times 8.
Now, I don't have a calculator, so I'm going to leave it like that. 8 to the 3rd is
8 3 times.
8 multiplied by itself 3 times. 8 squared is 8 times 8. 8 to the 1 is 8. And really, I shouldn't have to go back and evaluate all these, because when I get to the bottom, I should know that 8 to the 0 is going to be equivalent to what value?
Well, it's going to, anything to the 0 power, I'm understanding now, is going to be 1.
Yes. And that's all I need to write down for that is 8 to the 0 power is equal 1.
Right.
That makes sense?
Sounds good.
Now what can we change to be?
Well, I think we need to probably throw in some variables.
Okay. So let's just say that I've got a base of y. What would I write as y to the 3rd?
Okay, now, Miss Powell, these variables, I know that they're letters, but don't these letters represent numbers? They're just unknown numbers to us.
Yes. So they're unknown numbers. So there's some number that I have a base and it's raised to the 3rd power.
Right.
So I really can't evaluate it like I did a minute ago when my bases were numbers, but I can write it out longhand.
Right. So we've got these rules that we deal with that we call these power rules. And that's kind of what we're doing. They actually work with the variables too. Even though we don't know what the X and what the Y is, we can still use this common base with exponent rules.
So what do you think I'd write out as for y raised to the exponent of 3?
Well, I knew a while ago when you had the number 8, if it was 8 to the third power, it was 3/8. So it's going to be 3 y's here. Y times Y times Y.
So same premise as we did before.
What is premise,
I
Miss
think
Powell?
I made up a word.
What is premise? Did she just make that up? I think she did.
I teach math, so do not
Okay.
listen to my language arts skills.
All right.
So y squared.
We will forgive Miss Powell for that.
So y squared would be written how?
Y times Y. Y 2 times. Again, don't put the 3 in front of the Y and make it 3 times Y. That's not the same thing. It's not 2 times Y. It's Y times Y. So be real careful with that, okay?
So what would y to the 1 power be?
Again, 1Y is just Y.
What about y to the 0?
Okay, what do you guys think? Because a while ago when we had 8 to the 0 power, we had 5 to the 0 power, all those things to the 0 power equal what? 1. So anything, even a variable to the 0 power is equal to 1, okay?
Now what do you think we need to move to?
I don't know, Miss Powell. Maybe we're going to be multiplying with common bases.
Okay. So
Wow, look at that.
I've got a common base of x and a common base of 4. So they have, common base of x
Right,
and another
right,
common base
right.
of x.
Common base just means that the big number is the same in each term, okay? And so here's the thing that Miss Powell's getting ready to tell you is there's a rule that tells you kind of a shortcut what to do. So are you going to show them the longhand first, Miss
We're going to do
Powell?
longhand, then we'll
And
see
then
if
the
they
rule?
catch it. So let's just take x to the 3rd like we would have had a minute ago. How do we write that out long?
Well, that's 3 X's, right?
So x times x times x. Now what about x to the 4th?
Well, that's 4 X's.
X times x times x times x.
Miss Powell's
Now,
running out of room.
what do we do? If they had that multiplication dot, I can put that in there.
Right.
So basically, I just have a whole lot of x's that's being repeatedly multiplied.
How many X's do you have, Miss Powell?
1, 2, 3, 4, 5, 6, 7. So
Okay.
how can I rewrite that and simplify it? Because I can't evaluate it because
Right.
I don't have a number, but I can simplify.
Right. We don't know what X is. It's an unknown number to us, but we can put these things together with one common base.
And what is the common base?
It's an X.
Multiplied how many times?
Well, I see 7 X's down there multiplied together, so it's got to be X to the 7th power.
And that's how you would simplify it. You would write x to the 7th power.
Now, Miss Powell, to me, it seems like there's going to be an easier way to write that without having to write out all those X's. Is there an easier way you can tell me about here?
Well, I hope so. So let's say I went back and I had changed this to be x to the 37th and this
Whoa.
x to the 43rd.
I definitely do not want to write out all those X's right there, Miss Powell.
So if I have x to the 37th times x to the 43rd power, that'd be a whole lot of writing.
Yeah, we don't want to do that.
So your paper would look something like this and take you a long
No,
time
don't
to
do
do
it, Miss
that.
Powell. Don't do it.
So how would I figure out how many total x's I would be multiplying there?
Well, just a second ago, you had X to the 3rd, which was 3 X's,
Mhm.
and X to the 4th, which was 4 X's. And when we did that longhand and had it written all out, there were 7 X's. Why couldn't I just add the 3 and the 4 when I have a common base?
And that's what the shortcut is.
That's what we can do here.
So you can do 37. You have 37 x's being repeatedly multiplying, 43 x's being repeatedly multiplying.
Right.
And when you add them up, you would have got 80 x's. You would have had it written on your paper.
So what you're saying to me, Miss Powell, is if I have 2 terms multiplied, if they have like bases, I can just add the exponents.
Yes.
That's a great shortcut.
So how would you simplify x to the 37th power times x to the 43rd power?
Well, I'm going to keep the common base,
Which is
X,
x is my base.
and I'm going to add the 2 exponents, and it's going to turn out to be X to the 80th power. So I don't know, Miss Powell. Could I do this if I had different bases?
I don't know. Let's see. Okay, so let's say that I have a squared times b to the fourth times a to the fifth times a b. Now, if I made you do it longhand a minute ago, a squared would be saying that I had a multiplied by itself twice.
Right.
B to the fourth would be a b multiplied by itself.
Only
four
Miss
times.
Powell would do BBs. BBs. She's BBs.
Now, are these the same base right here?
A's and B's can't go together because they're not the same base. Is that what you're telling me?
Right. So you can't group these. Now,
Okay.
I can group the a's together. I have an a squared and an a to the fifth.
Right.
So a to the fifth would be multiplying a by itself 5 times.
You know what I just thought of, Miss Powell? Doesn't this go back to a property that we had called associative property? Isn't associative property where we can multiply in any order, and so the A's can go with the A's and the B's can go with the B's?
Yes.
Okay.
So basically,
I thought that was right. I learned that probably in Miss Harper's class.
Yeah, this takes too long to write out.
Yeah, that's way too long.
So let's do the shortcut.
Love the shortcut, Miss
So
Powell.
let's group
Shortcut, Miss Powell.
the shortcut. Yes, I'm short.
Miss Powell likes shortcuts.
So let's group the a's together.
Gotcha.
What's a squared times a to the fifth?
Okay, so I've got a common base of A,
A.
and then I know if I've got common bases, I can just add the exponents. So 2 plus 5 is 7.
Yep. Now I need to figure out the b's. I've got b to the fourth. Now this
Okay.
is weird because it's just a.
Oh,
B.
I remember this a while ago, and this was important because we said if we didn't have anything written, that doesn't mean it's a 0 or there's not an exponent. It means that there's a what? There's a 1.
Because I have a b there.
That's right. And you can put that 1 in there. That's okay. You don't have to leave it blank, or you can leave it blank, whatever you want to do.
I like sometimes putting it there. 'Cause
I do too.
Sometimes I accidentally go down here and put b to the fourth. And I
Right.
forget to add that extra one there. But if I had b to the fourth, that's b, 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 b. And then when I have another b, that gives me 5
Yeah.
that I'm multiplying.
You see, I never do that. I always remember that it's 1, Miss Powell, so I
See,
don't have to do it.
I do not.
But I do like it that it's written in there because that helps us to remember. That just shows my academic superiority over my partner down the hallway.
Okay, so let's do one more.
Well, before you do that, Miss Powell, tell me,
Yes.
why can't I make that AB to the 12th power?
Because you got to think of this as like apples and bears. You can't
Apples
mix
and what?
bears.
Apples and oranges in the land of Corbin is what we say. We don't say apples and bears. Where do the bears come in?
I don't know.
But Miss
So
Powell's
many.
exactly right. You can only put together if you have like bases. If it's a common base, you can put them under one base and add the exponents. If not, you have to leave them just like that. Okay.
And sometimes you'll see in homework, they'll just put the letters beside each other. You could actually put the
Sure.
multiplication
Sure.
symbol in between it, but you don't have to.
Right.
Okay, let's do one more.
It's an awful long lesson, Miss Powell.
I know. How
Lots-
many,
Long lesson, Miss Powell.
how many bases do we have here?
Whoa, lots of bases. But when you look at this, it kind of looks, really hairy and kind of distorted. And you're thinking like, oh my gosh, that's a big, long problem. But it's not really a big, long problem. If you look at it, is it, Miss Powell?
Nope. Now, how many bases I got?
Well, that's what you want to see because only C's can go together, only
Right.
D's can go together, and only E's can go together.
So I'm going to rewrite this, and I'm going to put the C's beside each other. Not the
You guys
D's.
see what Miss Powell did right there with the underline? That is a great strategy for you guys in problem solving.
Yes,
Put
it is.
together, Miss Harper, this is our video. This is not 7th grade video. Miss Harper, leave the room. Miss Harper, leave the room. We'll wait. Okay, good. Now, back to making sure that you underline. Great teaching strategy right there, Miss Powell. Underline common bases.
So now this one, it's C to the 0. So what's really C to the 0 equivalent?
Well, that's not going to trick us anymore because we know that anything to the 0 power, even a variable, is going to be just 1.
Right. So really, this becomes a 1. c to the 7. So really,
Right.
how many c's do I have?
Right. Just I've got C 7 times. But Miss Powell, do I even really have to write that one?
No.
Okay, here's a great question for you, Miss Powell. I'm going to test Miss Powell's vocabulary here.
Okay.
What is the number in front of a variable called?
In front of a variable is called the coefficient. But
Ding,
I
ding,
don't-
ding, ding, ding. Miss Powell wins a cookie.
So that is a coefficient that we'll get into
Right.
probably in the next
Right.
couple lessons.
Well, I'm sure if Miss Harper was in here, she would agree that her students were taught what a coefficient was. Surely they were taught what a coefficient was. Even, a bad teacher would teach the vocabulary coefficient. So,
Now I'm going to look. My next base is D. So I got D to the 4th.
well, how many
and
D's do you have?
A D.
Okay.
D to the 4th.
Yeah, I see
and
that.
A D. But what exponent would go here?
All right. So I know, remember, if it's no exponent written, that doesn't mean there's not one. That means that there's a 1. Okay.
So what would that give you? D to the 4th times D would be,
Common basis, add the exponents, D to the 5th.
and then we've only got one other base to simplify.
One thing I do too, Miss Powell, when I have lots of bases like this, when I'm done with them, I mark them out. Do you ever do that?
No, because sometimes I mess up on adding them, and when I mark them off, I mess up the numbers and I can't see them.
We don't ever mess up in the land of Corbin. That's only in the land of Powell. But I typically mark mine out when I'm done with them. That way I know that I don't have to go back and do anything with them.
But I do mark underneath them, so I know that I took care of them.
Yeah, and notice Miss Powell did 1 mark for the C's, 2 marks for the D's, 3 marks for the E's. I do like that.
Now, what about E to the 5th times E to the 8th?
Okay, again, common bases, guys, right? So what do we do with common bases? We put the exponents together by adding.
So 5 plus 8, 13. And that's as simplified as that problem can be. And it looks a whole lot better because it was kind of long. Now it's short. So in the next couple days, we're going to be doing some more rules over exponents.
Okay, guys, we appreciate you all tuning in. We will see you later.